Hello everyone, my name is Derek Reagan, and today we'll be discussing the future of solar energy storage. Why solar energy is important to the modern world. Fossil fuels are commonly used in our everyday lives, such as in our vehicles, as we drive to work and school and other places. The problem is that this source is finite and it is just a matter of time before those fuel sources run dry. The combustion of fossil fuels also makes a negative impact on the environment, with increasing signs of global warming and greenhouse gases as time goes on. Using solar panels is one of the most promising methods of energy creation for the future. The application of actually gathering solar energy through the panels is already in a decent state, but the methods used to store all of the captured energy is the root of the problem. The most commonly used method of storage is electrochemical battery storage. We're all used to seeing these in the department stores we go to all the time, and we usually think of them as effective and cheap for our everyday devices. The truth is that they're actually inefficient and expensive when used en masse. We just never really use them in anything that requires much energy. The system that I'll be talking about today is the compressed air energy storage. This is a method of storing generated energy for use in the future. This way, energy created at times of low demand can be saved and released for use at high demand. This system retrieves energy created from solar panels, transfers it into turbines, which then will power compressors that will compress air, which will be stored. The compression of air generates heat, and if this heat can be captured during the compression process, the system becomes more efficient as the byproduct is then turned into more energy. This process has massive economic feasibility due to the storage containers it uses. The main container used for the compressed air is usually underground caverns capable of holding immense amounts of pressure. The discussion of safety with CAES. Compressed air has safety concerns, as with most other technology involving it. The main concern being catastrophic tank rupture leads many to shy away from this developing technology. Safety regulations are put into place to make sure a rupture never occurs, such as pressure relief valves inside the containment unit. Regulations limit that the amount of pressure stored cannot exceed 40% of the rupture pressure or the pressure needed to cause a failure in the system. These are models of how the system will work, as solar energy will be taken from solar panels, transferred into turbines, which will power a compressor that will compress air, storing it in underground caverns. There are three main types of compressed air energy storage, the first being adiabatic. This would keep the heat produced by compression and return it to the air as it expanded to generate more power. The next, diabatic, dissipates most of the heat produced by the compression, essentially putting that energy to waste. This method allows for simpler storage, as the compressed air does not remain hot and therefore requires less maintenance. It must be reheated in the future in order to obtain the energy. Isothermal attempts to maintain high temperatures to have readily available energy by manually inputting heat into the storage component. This is only practical for lower power levels, as if you have a higher amount of air that you need to heat, it'll need more energy to heat it, therefore having less output. Applications for CAES air. Currently, the majority of vehicles use fossil fuels to power their engines, creating byproduct that leaks into the environment and hurts our world. For the future, many companies are in the process of developing compressed air cars, which will be able to directly take the compressed air from a CAES system and utilize it to power a motor. Large marine diesel engines are also beginning to use compressed air as a power source, allowing them to receive the necessary burst of extremely high power without placing too big of a load on the ship's electrical generators and distribution system. Hybrid vehicles also put compressed air to good use, as the air can be used for a regenerative braking system, which makes the engine cycle more efficient. This is an example of a developing compressed air car which will run completely on the compressed air. For the future, while using naturally made caverns is effective and economically productive, much is still to be desired, as there is a limited amount of naturally created structures suitable for containing such pressure. Being able to make containment units with cheap material, such as reinforced concrete, would drastically increase the efficiency of the system, as there would be no need to dig deep into Earth's surface in search of those natural caverns. The question is, what material would be best suited to create such a structure, and in what shape? And these are my sources.